Assalamualaikum and welcome to Cambridge Chemistry with Ms. Sarvademma. This is paper 1 multiple choice questions from mini series July 1 to from May June 2021. Let's start. Three pieces of apparatus are shown. This is burette, measuring cylinder and pipette. Which piece of apparatus could be used to measure 23 centimeter cube of liquid? 23 centimeter cube of liquid is not measured with exactly 23 centimeter cube is not measured with the pipette because it is measured 25 centimeter cube of the liquid. Burette and measuring cylinder. So these two apparatus, measuring cylinder and burette, can be measured 23 centimeter cube of liquid. A burette and measuring cylinder, so this must be correct. Burette and pipette only, this is not correct. Burette, measuring cylinder and pipette cannot. Pipette cannot, burette can be. Measuring cylinder and burette can be. Measuring cylinder and pipette only. Measuring cylinder can be used but pipette cannot. So A option is correct. Copper 2 nitrate is soluble in water. Copper 2 carbonate is insoluble in water. A mixture of solid copper 2 nitrate and copper 2 carbonate is added to beaker of water. It is stirred until no more solid dissolves. Mixture of copper 2 nitrate CuNO3 twice plus CuCO3. So this is added to beaker, and this is insoluble in water and this is soluble in water. So when we dissolve in water, copper 2 nitrate dissolve in solution water, but copper 2 carbonate cannot. So it become aqueous and CuCO3 remain insoluble in water. How can separate sample of copper 2 nitrate and copper 2 carbonate be obtained from the resulting mixture? Copper 2 nitrate and copper 2 carbonate. Because it is insoluble in water, it is through filtration, and it is as a residue, and copper 2 nitrate soluble, so it is through crystallization because it is in the form of filtrate and through crystallization. So these two processes are used to separate sample of copper 2 nitrate and copper 2 carbonate. Crystallization followed by distillation. No, crystallization, this is incorrect, this is also incorrect. Evaporation followed by distillation. No, this is not correct. Evaporation, so we cannot obtain crystals by using evaporation, and distillation is not suitable for this method. Evaporation followed by filtration. So evaporation again not suitable for crystallization, so filtration is not exactly. So this is, we just add the water and then first filtration to remove solid followed by crystallization. Removed solid followed by crystallization. So D option is correct option. Filtration followed by crystallization. Question number 3. Two compounds P and Q are separately dissolved in water and tested as shown. Test one, color of solution green, colorless, color of solution green, colorless. Aqueous sodium hydroxide added, green precipitate soluble in excess giving green solution. This is for chromium. And white precipitate insoluble in excess, white soluble in, this is for Q. White precipitates insoluble, this is colorless, white soluble, any ions can be white ions can be insoluble, that calcium is only insoluble in excess. So aqueous sodium hydroxide and aluminum foil added, then warm. This is test of nitrate ions. No gas is given off. This is incorrect observation. Ammonia gas given off. So in Q, nitrate ions are present, but in P, nitrate ions are absent. Acidified with nitric acid, then aqueous barium nitrate. White precipitate, this is positive test of sulfate ion, and this is no precipitate, this is incorrect for sulfate ions. Which ions are present in P and Q? P and Q. In P, chromium ion and sulfate ions are present, while in Q, calcium ions and nitrate ions are present. So chromium and sulfate is correct, but zinc and nitrate is incorrect because zinc is soluble in excess. B option, chromium and sulfate, is correct. Calcium and nitrate is also correct. So B option is correct option. Iron 2 and nitrate ions. Iron 2 is green precipitate but insoluble in excess of sodium hydroxide, so that's why it is not correct. And nitrate is not in P, so this is also incorrect. Calcium is correct, sulfate is not correct because nitrate ions are present in Q. Iron 2 ions and nitrate ions. Iron 2 ions incorrect, nitrate ions are correct. Zinc and sulfate is also incorrect. So option B is correct option. Which statement is correct? When gaseous ammonia becomes liquid ammonia, the change is endothermic. When aqueous ammonia becomes liquid ammonia, aqueous ammonia NH3, aqueous become when gaseous ammonia become liquid ammonia NH3, the reaction is this is condensation reaction, and condensation is not an endothermic reaction, this is exothermic reaction, so first option is incorrect. When liquid ethanol becomes solid, when liquid ethanol, this is ethanol liquid, becomes solid, this is freezing, and freezing is exothermic reaction, so this option must be correct. This option must be correct. When liquid water becomes gaseous water, liquid become water, become gaseous water. This is evaporation, and evaporation is endothermic, so this is also incorrect. When solid copper, this is D, this is C. When solid copper becomes liquid copper, Cu liquid, so solid copper become liquid copper, this is melting, and melting is endothermic, so this is also incorrect. B option is correct. Which diagram shows the lithium uh, lithium positive ions? Which diagram shows the positive ions? So lithium positive, proton, neutron, and so A, lithium has 3 and 7, 3 proton, 3 electron, and 4 neutron. 3, this is incorrect because 3 proton, so all are protons there. 4 protons, this is incorrect. And B option is 1, 2, 3, 3 proton, and 1, 2, 3, 4, 5, 6, 7 neutron. This is also incorrect. There should be 4 neutron. And C options 1, 2, 3, 3 protons are correct. 1, 2, 3, 4 neutrons are also correct, and 2 electrons are correct because lithium carrying positive 1 electron has to be removed. So this option is correct. D option is also incorrect because 1, 2, 3, this is lithium atom. This is lithium atom, not lithium ion. So this is also incorrect. Question number 6. 3 statements about the elements carbon, nitrogen, and sulfur are shown. They are in group next to each other in the periodic table. Element carbon, nitrogen, sulfur. Carbon is present in group 4. Nitrogen is present in group 5. And sulfur is present in group 6. They are in group next to each other in the periodic table. Yes, they are present in groups next to each other in the periodic table. This statement is correct. Their neutron to proton ratios are all 2 to 1. Carbon is 6, 12 and 6. Nitrogen is 7 and 14. And sulfur is 16 and 16 and 32. Their neutrons to proton ratio in this 16 protons, 7 proton, and 7 neutron. Neutron to proton ratio. So carbon is 7 neutron and 7 proton. Nitrogen is 7 neutron, here is 6 proton and 6 neutron, carbon 6 neutron, 6 protons, nitrogen 7 neutron, 7 proton, and sulfur 16 neutron, 16. There is 1:1 ratio. So this statement is incorrect. They each form an acidic oxide. This statement is correct because all are non-metals, and carbon form carbon dioxide, nitrogen form nitrogen dioxide, and sulfur form sulfur dioxide. So all form acidic oxide. So this statement is correct. 1, 2, 3 is incorrect. 1 and 2 is also incorrect. 1 and 3 is correct option. 2 and 3 also incorrect. Question number 7. The table shows data for some particles. There are gaps represented by W, X, Y, Z. Particles argon, potassium ion, and scandium and sulfur 2 minus sulfide ion. 18, proton number 18, nucleon number 40, and number of neutron will be number of neutrons if 40 minus 18 is equal to 22, so the number of proton is 22. K positive 19, 39 is the nucleon number, 20 is the number of neutrons, and X is the number of electrons. So X will be, because number of proton is 19 and potassium positive charge 1 electron, potassium loses 1 electron, so the number of electron will be, after losing 1 electron, it will be equal to 18. Scandium 21, 24, nucleon number is number of proton is 21, number of neutron will be 24, so 24 plus 21 is equal to 545. So here 45, and 2 minus 16 is proton number, and nucleon number is 32, number of neutron is 16, and what would be the number of electrons? Z. We know that number of proton is equal to the number of electron, so sulfur gains 2 electrons, so it is 2 more than number of protons, so it will be 18. Sixteen is the proton number, 16 is the neutron number, and 16 plus 2 is equal to 18. Question number 7. Which row shows the correct values W, X, Y, Z? W will be 22, so these two are incorrect. Now look at these two. 22 is correct. Now what value of X is 18, this is correct, and value of Y is 45, this is also correct, and value of Z is 18, but this is 14, this is incorrect. So D option is correct, because 22 is W, 18 is X, and 45 is Y, and 18 is Z. So D option is correct. Hydrogen can form hydrogen positive ions and hydride ion. Which statement is correct? An hydrogen ion has more protons than hydride ion. So both have same number of protons. Hydride ions, this is hydrogen ion, 1 proton. So H positive, no electron, no neutron. So this is hydride ion, proton 1, neutron 0. So same number of proton 1 and proton 1, so there is no more proton, so this is incorrect. And hydrogen ion has no electron. Yes, hydrogen ion has no electrons in shell, so this must be correct. And hydride ion has 1 more electron than hydrogen ion. Hydride ion has hydrogen ion has proton, it has no electrons, so that's why it is also incorrect. And hydride ion is formed when a hydrogen atom loses an electron. Hydride ion is formed when hydrogen atom gains electrons, so this is again incorrect. B option is correct. Iodine and sodium chloride are solids at room temperature and pressure. Which row correctly shows the structure of iodine and the bonding in sodium chloride? Iodine is non-metal. Iodine is present in group 7, and sodium is present in groups Iodine is exists in molecule, diatomic molecule. Sodium chloride, because sodium is metal, chlorine is non-metal. So when metal non-metal react, ionic compounds are formed. And iodine is a simple molecule, because iodine exists in diatomic form, I2. Giant moleculars, no, it is correct. Simple molecule, covalent, not correct. A option is incorrect. Giant molecular, ionic, it is correct. Simple molecular, iodine is a simple molecular. Sodium chloride is not covalent, so this is also incorrect. Simple molecular, iodine is simple molecule, and sodium chloride is an ionic compound. So this is correct, this is correct, D option is correct. It is possible to produce Ar2 positive ions, argon 2 positive ions from organ atom in a laboratory. Which statement is correct? Each argon atom gains 2 electrons and loses the electronic configuration of inert gas. Not gains 2 electrons. When positive charge is formed, atoms loses electron, and this is incorrect. And electronic configuration, yes, loses electronic configuration of an inert gas. This is incorrect. Each argon atom gains 2 electrons, not gains 2 electrons, and obtains the electronic configuration of an inert. This is incorrect. This is also incorrect. See, each organ atom loses 2 electrons and loses the electronic configuration of an inert gas. So both statements are correct. So C option is correct. Each organ atom loses 2 electrons. Yes, loses 2 electrons and obtains the electronic configuration of an inert gas. So this is also incorrect. Question number 11. Many elements and compounds contain covalent bonds. Which statement about covalently bonded elements and compounds is correct? Compounds contain covalent bonds. Aqueous solution of covalent compounds always conduct electricity. This is incorrect. Covalent compounds do not conduct electricity because they do not dissociate into ions. They don't have free moving ions. Free moving ions. Bonding, so it is incorrect. Bonding in the bonding in the nitrogen molecule involves 3 shared pairs of electrons. Yes, it must be correct, because nitrogen have triple bonds and shares 3 pairs of electron. So this is the structure of nitrogen molecule, so this must be correct. Double covalent bonds are present in ethene and in water. In ethene, double bond is present, but in water, single bonds are there. So this is also incorrect. The formation of covalent bonds always produces atoms with 8 electrons in their outer shells. The formation of covalent bonds not always produces atoms with 8 electrons, because hydrogen has 2 electrons in their outer shells. So this is also incorrect. What is the number of moles of hydrogen atoms in 3.2 gram of methane? Number of moles of hydrogen atoms in 3.2 grams of methane. Methane is CH4. So the MRA of methane is carbon 12 416. So 3.2 gram mole is equal to mass over mr. Mass is 3.2 divided by 16. 3.2 divided by 16 is equal to, this is 0.2. So this is number of mole is 0.2, and because what is the number of moles of hydrogen atoms? 1 mole, number of moles of hydrogen atoms. CH4 is 1 mole, and number of moles of moles ratio atom. 1 mole of CH4, 1, so this is not like this. CH4 has CH4 has 1 mole of CH4 has 4 hydrogen atoms. So what would be the mole of number of atoms in 0.2 moles of CH4? This is X, so do cross multiply, and this the answer is 0.8. Question number 13. What is the ionic equation for the reaction between aqueous silver nitrate and aqueous iron 3 chloride? Silver nitrate and iron FeCl3 AgCl plus FeNO3 thrice. So this is aqueous, this is aqueous, this is solid, and this is aqueous. So 3 thrice, this is 3Ag and 3Ag Cl, and this is balanced reaction. Now NO3 is cancelled out, 3Ag positive, 3NO3 negative, plus Fe3Cl minus to form 3AgCl plus Fe3 plus 3NO3 thrice. This is aqueous. Same aqueous ions are cancelled out. Remaining would be the ionic equation. So iron 3 ions are same, nitrate ions are same. So left behind will be 3Ag plus 3Cl minus to form 3AgCl. Because 3 is common, so we cancel this, and the ionic equation will be Ag positive plus Cl negative to form AgCl. Solid, aqueous, and aqueous. Ag positive 3 ion, this is incorrect. Ag positive, Cl negative, AgCl aqueous. This is correct, this is correct, this is incorrect. Ag positive is correct, Cl negative is correct, Ag solid is also, so C option is correct. So iron 3 is aqueous, 3 nitrate nitrate is aqueous, FeNO3 thrice. This is not correct because this is not ionic equation. All are cancelled out, so this is also incorrect. The correct ionic equation is C. The best option is C. Calcium carbonate reacts with an acid Ha. Calcium carbonate plus 2Ha to form CaA2 plus H2O plus CO2. What is the minimum mass of acid required to react with 10 gram of calcium carbonate? What is the minimum mass of acid? Minimum mass of acid is so first calculate the mole of carbonate. Mole is equal to 10 gram divided by 100. The answer is 10 divided by 100. The answer will be 0.1. And mole ratio calcium carbonate ratio acid CaCO3 ratio Ha 1:2, and the mole of calcium carbonate is 0.1, and mole of Ha is equal to 0.2. So the mass of Ha is equal to Mr is given, so mole into Mr. Mole is 0.2, Mr is 46. The answer is 0.2 into 46. The answer is 9.2 gram. B option is correct. When 1.0 mole per dm cube hydrochloric acid reacts with excess sodium carbonate hydrochloric acid, 1.2 dm cube of carbon dioxide is produced, measured at room temperature and pressure. Which volume of 1 mole per dm cube of HCl is used? So this is 1.2 dm cube of carbon dioxide. So let's find out moles of CO2 is equal to 1.2 divided by 24 dm cube. Mole is 1.2 divided by 24, it is equal to 0.05. And let's find out the mole ratio. Sodium carbonate ratio HCl 1:2. The moles of carbon dioxide mole ratio, HCl ratio carbon dioxide, HCl ratio carbon dioxide 2:1 and 0.05 ratio X. 0.05 into 2, which is equal to 0.1. This is 0.1, and we have concentration 0.1 mole per dm cube. the volume is equal to mole over concentration, because volume is centimeter cube, so it is multiplied by 1000. So mole is equal to 0.1 divided by volume is equal to 0.1 divided by, this is concentration, into 1000. So the answer is 1000. 0.1 multiplied by 1000 is equal to, this is 100, and 100 divided by 1, this is 100 centimeter cube. So B option is correct. Question number 16. Which solution contains the same number of moles of solute? 10 centimeter cube of 0.01 mole per dm cube copper 2 sulfate. Number of moles of solute. So this is mole is equal to concentration into volume divided by 1000. Concentration is 0.01 into volume is 10 centimeter cube divided by 1000. This is equal to 0.01 into 10, 0.1 divided by 1000 is equal to 1 into 10 raised power 2 minus 4, 0.001. 100 centimeter cube of 0.05 mole per dm cube sulfuric acid. This is 0.05, this is 2, this is 1. 0.05 into 100 divided by 1000, this is equal to 0.05 into 100 is equal to divided by 1000, this is 0.005, 0.005. 100 centimeter cube of sodium hydroxide. Hundred 0.001 into 100 divided by 1000. 0.001 into 100 is equal to divided by 1000. This is 0.0001 and 4 is 0.1 mole into 50 divided by 1000. 50 divided by 1000 it is equal to 0.05. So which solutions contain the same number of moles of solute, that is 0.001 and 0.0001 is same, so 1 and 3 option is same. So option A is 1 and 3, this is correct option. 1 and 4 is incorrect because 0.05 and 0.0001, this is incorrect. 2 and 3 also incorrect. 2 and 3 is not same, and 2 and 4, 2, 0.005 and 0.05, so A option is correct. Which statement about the electrolysis of concentrated aqueous sodium chloride is correct? Electrolysis of aqueous sodium chloride is correct. Chlorine is produced at the cathode, so it is incorrect. Chlorine is produced at anode. Hydrogen is produced at the cathode. Yes, hydrogen is produced at the cathode. This must be correct because at anode 2Cl negative, Cl2 plus 2 electron. At cathode, this is a cathode reaction. 2 hydrogen ions gains 2 electron to form hydrogen gas. So hydrogen gas is the product of cathode, so this must be correct. Oxygen is produced at the cathode. This is incorrect because oxygen is produced from OH ion, and this is the reaction at anode. This reaction is O2 plus 2H2O plus 4 electron, so this is incorrect. Sodium is produced at the cathode. Sodium do not discharge at cathode because hydrogen is lower in the reactivity series than sodium, so this is the preferential discharge of hydrogen ion at cathode, so this is also incorrect. Question number 18. The equation for 3 reactions are shown. Carbon to form carbon dioxide, aluminium, 2 oxide ion to form oxygen, and 4 electron. Which reaction occur in the extraction of aluminium from purified aluminium oxide? Which reaction occurs in the extraction of aluminium purified? So this reaction occur at cathode, this reaction occur at anode, this is correct. And when oxygen is produced at anode, because anodes are carbon rods, so it start reacting with oxygen, carbon rods, and start reacting with carbon rods to form carbon dioxide, so this is also correct. So all 3 reactions occur in the extraction of aluminium from purified aluminium oxide. So which reactions? 1, 2 incorrect, 2 incorrect, 2 and 3 incorrect. D option is correct. Question number 19. An energy profile diagram is shown. This is reactants. An energy profile diagram is shown. Reactants, products, and 100 kilojoule per mole, 100 kilojoule per mole. Okay, which row shows the activation energy of the reverse reaction and the description of the forward reaction? This is the activation energy. This is the activation energy of reverse reaction. This is activation energy of reverse reaction. Because reverse reaction is endothermic, so this will be reactant, for reverse reaction. And this will be product. Which row shows the activation energy of the reverse reaction and the description of the forward reaction? Description of forward reaction. The activation energy must be 100 plus 100 is equal to 200 kilojoule. So these two are incorrect. Go to the C and D. So 200 correct option, and more energy is given out forming bonds in the products than is taken in the breaking the bond in reactants. Yes, it is. It must be correct because this is forward reaction is exothermic, and more energy is released in bond forming than heat gained in bond breaking. This is bond breaking, and this is bond forming. So this is so C option is correct. Question number 20. Petroleum crude oil is a mixture of hydrocarbon which can be separated into fractions by fractional distillation. Which row correctly shows the fractions in order of decreasing boiling point? Diesel. So this is the fractional distillation. Over here petroleum gases, then petrol, naphtha, petrol, naphtha, kerosene, diesel. Lubricating oil, this is bitumen. So which row correctly shows the fractions in order of decreasing boiling point? So highest to lowest. Diesel is the highest, then kerosene, then naphtha, then petrol. So A must be correct. Let's check other. Naphtha, then petrol, then diesel is incorrect, then paraffin is incorrect. Paraffin, naphtha, naphtha is petrol, and petrol to diesel. This is incorrect. Petrol, this is the lowest, this is highest, so this is incorrect. So A option is correct option. The rate of chemical reaction decreases as the temperature decreases, because at a lower temperature, at a lower proportion of molecules have energy that exceeds the activation energy. Yes, a lower proportion of molecules have energy that exceeds the activation. This is correct. The molecules are further apart. The rate of chemical reaction decreases as the temperature. No, molecules are not further apart because at lower temperature molecules are closer up. So this is incorrect. the frequency of successful collision is less. So by decreasing temperature, collision of um, molecules become less. So this is correct. 1 and 3 are correct, so option B is correct. 1 and 2 is incorrect. 2 and 3 is also incorrect. 1, 2, 3. The rate of reaction between a metal carbonate and dilute acid is followed by a measuring of volume carbon dioxide produced and plotting this against time. The line labeled X shows the results of an experiment using 50 cm³ of 1 mole per dm cube hydrochloric acid and excess metal carbonates. The experiment is repeated using different conditions and lines Y and Z are drawn to show the volume of carbon dioxide produced against time. Which row shows the conditions that could give lines Y and Z? Line Y and line Z. "50 cm³ of 0.5 mole line Y, 50 cm³ of 0.5 mole per dm cube hydrochloric acid at same temperature, 50 of 1." So this is correct because over here 1 mole per dm cube and condition Y concentration become lower, volume remain the same. So this must be correct. 25 cm³ condition for Z. 25 cm³ of 2 mole per dm cube hydrochloric acid at same temperature. Concentration is higher, so more products are formed. When we increase the concentration, 25, let's calculate mole, 0.5 into 50, 0.5 into 50 divided by 1000. So in this reaction 0.00025 and this reaction 2 into 25 divided by 1000 is equal to 2 into 25 divided by 1000 is equal to 0.05. This is 0.05 and the question is metal carbonate and dilute acid is followed. Results of experiment using line X. Line X is of 50 cm³ into 1000. This is equal to 50 divided by 1000 is equal to, this is 0.05. So this is 0.05 moles and this is 0.025 moles. So for Y it is correct, for Z 0.05, there is also 0.05. So this is not for Z, so this is incorrect. Your 50 cm³ of 0.5 mole per dm cube of hydrochloric acid at same temperature with catalyst Y. Yes, this is correct because the reaction is steeper and this is more uh, this is faster than X, which has 0.05 moles. Because catalyst is used, the rate of reaction is line is steeper. 12.5 centimeter cube divided by 1000 into 4. 12.5 divided by 1000 into 4 is equal to, this is again 0.05. So this is correct for Z. So B option is correct. At same temperature, 50 centimeter cube of 1 mole, 1.0, this is 0.5. 50 centimeter cube, 50 divided by 1000, 50 divided by 1000. So this is 0.05 moles. So this is incorrect. 50 centimeter cube of 1 mole, this is again 0.05, incorrect. 0.50 centimeter cube of 0.5, 50 centimeter cube of 1 mole per dm cube H2S. This is HCl, and this is H2SO4. This is further reduced because 2 moles of hydrogen ions are there. So this is also incorrect. B option is correct. In which equation is the underlying substance oxidized? Here it is 0, 3 plus, manganese plus 7, and Mn plus 2. We know how to calculate the oxidation state. This is Cr2O3, Cr2O3, chromium Cr2O3 is equal to 0. So 2x plus 3 minus 2 is equal to 0. 2x minus 6 is equal to 0. 2x is equal to 6, x is equal to plus 3. This is plus 3 and this is also plus 3. Plus 7 is going to reduced, Mn carrying plus 7. So this element, underlined element, no need to solve this, only underlined. This is underlined element, manganese. In manganese 4 oxide, this is MnO2 is equal to 0. Mn plus 2 minus 2 is equal to 0. Mn plus minus 4 and Mn is equal to plus 4. So over here plus 4 and over here plus 2. So this is going to reduced. This is not oxidized. This is incorrect. Na2SO3. Na2SO3. So over here plus, sulfur is plus 6, and so this is underlined element, sodium sulfide, Na2. Compound decolorizes acidified potassium manganate. What could this, sodium sulfite Na2SO3 is equal to 0. Sodium is 2x plus sulfur minus 2 plus oxygen 3 minus 2 is equal to 0. 2x minus 2 minus 6 is equal to 0. 2x minus 8 is equal to 0. 8 or x is equal to 4 plus 4 and over here plus 1. So this is also reduced, not oxidized. This is also incorrect. NO2 N plus 2 minus 2 is equal to 0. N minus 4 is equal to 0. Over here plus 4. N is equal to plus 4 and over here NO plus 2. So this is also incorrect. This is also reduced. Only A option, where aluminum is going to oxidized after losing 3 electron to form 3 plus charge. So A option is correct. Question number 24. A compound decolorizes acidified potassium manganate 7. What could this compound be? Manganese chloride, MgCl2. Iron. What could be decolorizes acidified potassium manganate? Magnesium chloride, iron 2 chloride. Compound decolorizes acidified. Yes, iron 2 chloride act as a reducing agent. It can react with potassium manganate and color is purple to colorless. Ethanol also acts as a reducing agent, so it also decolorizes potassium manganate. Same color changes. So option 2 and 3, this is incorrect because magnesium chloride not act as a react with potassium manganate, acidified potassium manganate. So 3 option 2 and 3 are correct. So C option is correct option. If a sample of ammonia is passed over heated iron, two gases X and Y. If sample of ammonia is passed over heated iron, Fe plus NH3 to form two gases X and Y are formed. Gas X react with oxygen and gas Y is gas X react with hydrogen. Two gases X and Y are produced. This is heated cat iron passed over. Ammonia is heated over iron to form two gases X and Y. Gas X reacts with, this is hydrogen plus nitrogen. Gas Y is unreactive. So this is unreactive gas and this hydrogen react with oxygen to form water. Which statement is correct? Gas X reacts with oxygen to form, this must be correct. Gas Y is a compound. No, gas Y is not a compound, it is a molecule. The formation of two gases from ammonia cannot be reversed. It can be reversed. It again form ammonia gas. So it is incorrect. There is triple bond in one molecule of gas X. Gas X has a single covalent bond. H. So this is also incorrect. A option is correct. The equation shows the reaction for the formation of sulfur trioxide using catalyst. Which change in the reaction condition would produce more sulfur trioxide? By adding more catalyst does not affect the yield of the product. So it is catalyst only speed up the reaction, rate of reaction. Decreasing the pressure will favor the forward reaction, so it is also incorrect. Not producing more sulfur trioxide. Increasing the temperature, also reaction will be reversed back because reaction is exothermic, so this is also incorrect. Removing some sulfur dioxide, yes, sulfur trioxide. When we remove sulfur dioxide, there is less concentration of sulfur trioxide over here, so that's why more sulfur trioxide is going to produce. So this option is correct option. Ammonia gas is produced by heating mixture of ammonium chloride and calcium hydroxide. How can this reaction be described? Ammonium chloride, calcium hydroxide. Calcium chloride, ammonia and water is formed. Decomposition, this is not decomposition reaction because ammonium salt is acidic salt and this is base. Redox reaction, it is not redox reaction because nothing can be changed with oxidation state. So these two are incorrect. And acid base reaction, this must be correct because ammonium salt is acidic salt and when it react with calcium hydroxide act as a base, so it must be acid base reaction. And exothermic reaction is not correct because over here 444 endothermic reactions. A student prepares a pure sample of barium sulfate. The student dissolves 0.1 barium chloride in water, adds an excess of aqueous sodium sulfate. The equation for this reaction is shown. Which statement is correct? 0.1 mole of sodium chloride is produced. 0.1 mole of barium chloride, 0.1 mole. The equation is shown. Which statement is correct? So 0.1 mole of barium chloride in water and then adds an excess of aqueous sodium sulfate. So this is excess, so this cannot be equal to 0.1. Sodium sulfate is excess. 0.1 mole of sodium chloride is produced. A giant ionic lattice is produced. Giant ionic lattice is produced. This is in solid state. After filtering the reaction mixture, barium sulfate is obtained by no, this is not obtained by crystallization, the filtrate. This is insoluble salt. Insoluble salt. This is as a residue. Aqueous sodium sulfate can be used to test for chloride. Aqueous sodium sulfate is not used, cannot be used to test for chloride ions. Silver nitrate can be used to, so a giant ionic lattice is produced. So this, though both are ionic compounds, so barium sulfate is solid, so giant ionic lattice can be produced. Which pair of reagent is most suitable for the laboratory preparation of copper 2 chloride? Copper 2 chloride is soluble salt, So this is produced by using filtration and crystallization, and crystallization. So in filtration and crystallization, copper 2 chloride is produced by using copper 2 oxide plus HCl to form copper chloride plus water. So copper cannot react with dilute HCl. No reaction because copper is least reactive matter. So in copper nitrate also cannot sodium chloride because both copper nitrate and sodium chloride. So this is not the method used in filtration, and this is not suitable both aqueous solution. One must be solid and other reagent must be aqueous, which is used in filtration and crystallization. So copper 2 oxide, this is incorrect. Copper and chlorine is incorrect. Copper and dilute hydrochloric acid is also incorrect. Copper 2 oxide and dilute hydrochloric acid. Titration and precipitation are two of the methods used in salt preparation. In which row could the salts be prepared by this method? Titration and precipitation are two of the methods used in salt. In which two row could the salt be obtained? In titration, soluble salts are formed, soluble salts of group 1. And in precipitation, insoluble salts are produced. Calcium sulfate is insoluble, cannot produced by titration. Lead 2 chloride is also insoluble. It can be produced by precipitation. So this is incorrect. Magnesium chloride is soluble salt which cannot be produced by titration because magnesium oxide is insoluble compound. It can be produced by filtration and crystallization. Iron 2 sulfate is aqueous salts, cannot be produced by precipitation. Potassium chloride can be produced. Silver chloride can be produced by precipitation. C option is correct. Sodium nitrate and copper 2 sulfate both are aqueous salts. This can be produced. Copper 2 sulfate not. It is aqueous salts, cannot produced by precipitation. The manufacture of sulfuric acid by contact process involves three main reactions. Sulfur dioxide, first stage, key stage. This is the key stage. Sulfur trioxide, this is the not the suitable method. Which reactions are oxidation process and which requires the use of catalyst? The key stage requires the catalyst, vanadium 5 oxide V2O5, and which is oxidation. Which reactions are oxidation? These reactions are oxidation 0 plus 4 oxidation state, oxygen, or in other words we can say sulfur gains oxygen, it is oxidized. This is oxidation. Plus 4 and plus 6, this is also again oxidation. This is not oxidation because plus 6 and over here plus 6. So 1 and 2 are oxidation process, and this is not oxidation, and vanadium 5 oxide is used in reaction 2. So this is incorrect. 1 and 2 is also used as a catalyst, not used only in 2 is used as a catalyst, vanadium 5 oxide. This is also incorrect. 2 is correct. 1 and 2, these two. 1 and 2 is incorrect. 2 only is correct. So D option is correct option. Some information about elements X and Y is given. Elements X and Y exist as diatomic molecule. Element X has lower boiling point than Y. Which row shows possible identities for element X and Y? X over Y exist as diatomic. All are halogens exist in diatomic. Halogens are chlorine, group 7 elements are halogens: fluorine, chlorine, bromine, iodine, astatine. So all exist in diatomic group 7. X has lower boiling point than element Y. X has lower boiling point than Y. Bromine melting and boiling point increases, and boiling point increases downward. X and Y exist as diatomic. Bromine is diatomic, iodine is also bromine. Iodine is placed below than bromine, so bromine has lower boiling point than iodine. So A must be correct. Bromine and chlorine. Chlorine is above, then so both are diatomic, but chlorine is not a good option because bromine has higher boiling point than chlorine. Neon and argon, this is noble gases, monoatomic. These are monoatomic gases, not diatomic gases. So this is incorrect. Potassium and sodium, this is group 1 element, not diatomic. Not diatomic. So A must be correct. Iron is produced in the blast furnace. Waste gases. Which statement about this process is correct? Carbon is oxidized to carbon dioxide. Yes, carbon is oxidized. This must be correct. Let's check other. Carbon monoxide is produced by the thermal decomposition of calcium carbonate. So it cannot be produced by thermal decomposition. Calcium oxide and carbon dioxide is, so this is incorrect. Hematite is reduced by calcium. No, hematite is reduced by carbon monoxide, Fe plus CO2. Impurities are removed by hot air. No impurities are not removed by using calcium oxide plus silica act as an impurity. So impurities are removed by this process is, so this is also incorrect. A option must be correct. 34. Some pollutants enter the air by natural process. Which natural process release pollutants into the air? Which natural process remove nitrogen? Question number 34. Some pollutants enter the air by natural process. Which natural process release pollutants into the air? Bacterial decay of vegetable matter. Yes, bacterial death, and this is the source of methane gas. Bacterial decay of vegetable matter. Some pollutant by natural. This is the natural process. And which natural process release pollutant into the air? This is death and decay of vegetation producing CH4. Lightning activity. This is also a natural process, oxide of nitrogen. Volcanic eruption, also natural process, natural, and producing sulfur di and sulfur trioxide. So 1, 2, 3 statements are correct. So 1 and 2 is incorrect, 1, 3 incorrect, 2 and 3, D option is correct option. Which statements about the pollution and purification of water is correct? Carbon is used to disinfect water for drinking. Carbon is used to not disinfect water, it is removes odor. This is incorrect. Desalination produces drinkable water by using fractional distillation. Desalination produces drinkable water by using not fractional distillation, simple distillation. So this is also incorrect. Eutrophication results in water having too little dissolved oxygen. Yes, this is incorrect because eutrophication, this is unintentional growth of algal plant. Unintentional growth of algal plants due to excessive use of fertilizers and spread on the surface of water cover block sunlight used dissolved oxygen. So it means when it uses dissolved oxygen will be less. This must be correct. Nitrates from detergent results in restrict plant growth. No, nitrates from fertilizers. Nitrates not restricts plant growth, it improves the plant growth. So this is also incorrect. D option is correct. Question number 36. The structures and names of 4 alkanes are given. Cyclobutane, methylbutane, dimethylpropane and butane. Which 2 alkanes are isomers of each other? So this is cyclobutane, this is C4H8, this is 1, 2, 3, 4, 5, this is C5H12, methylbutane 1, 2, 3, 4, 5. So this is also 1, 2, 3, 4, 5. Dimethylpropane, this is also C5H12 and this is C4H10. So 2 and 3 have same molecular formula but different structural formula, so they are isomers of each other. 2 and 3, because both compounds have same molecular formula but different structural formula. So 2 and 3 is correct.